For this problem, we have a crate on an incline. The mu sub k is 0.2, and they tell us the x and y direction, and then we also know the direction of the incline. And they want us to find the acceleration in the x direction and tell us that the mass of the block is 10 kilograms. So we start just the same as the others, where we do free body diagram equals the kinetic diagram. So let's draw a free body diagram. We have this crate. Equals that. I'm just putting the x and y coordinates on there. All right, and then our forces on the left one, so we're going to have a normal force pointed up. We have the force of friction. We have the weight of it. And that's going to be all on that side. And then for this one, we have the G is going to be at the center. And that's going to be mass times acceleration in the x direction. And we know some of these values. So like the force of friction is going to equal mu sub k times n. So that's going to equal 0.2 times n. The weight is going to equal that 10 kilograms times 9.81 meters per second squared. So that equals 98.1 newtons. And then I think that's it. So we have too many unknowns probably here, right? So we have force of friction in terms of n, and we have the n as an unknown. We know the weight. We know the mass. We don't know the acceleration. So we have two unknowns. So we could, start by summing the forces in the x direction. So let's see, if we sum the forces in the x direction equals max, we're going to have two unknowns in that equation. So we can also sum the forces in the y direction equals, in y direction, then we look over here and we don't have any a sub y, so that's just going to equal 0. And that'll help us get to the n, to figure out what n is. So that's going to equal n, and then minus that y component of the weight. Oh, I forgot to put the direction in there. But the y component of that weight is going to be cosine, or the 98.1 newtons times cosine of 30 degrees. So it's just that weight that we calculated times cosine of 30 because it's adjacent. And then the F force due to friction is in the x direction. So we don't have to worry about that one. That equals 0. And so N is going to equal 98.1 times cosine of 30, which is going to equal 84.96 newtons. It is kind of confusing with the N and the N, but so the N force is going to equal 84.96 newtons. Now we can go back to this equation. So sum of the forces in the x direction equals max. So look at the free body diagram to get the forces in the x direction. So we have negative force of friction. So negative force of friction. The normal force is all in the y direction, and then the weight is in the positive direction, so 98.1 newtons. And then we want just that y component, so sine of 30 degrees is going to equal, the mass is 10 kilograms times a sub x, and we're looking for that a sub x. That force of friction we found to be negative is 0.2 times that normal force, so 84.96 newtons. 98.1 newtons sine 30 degrees, all divided by 10 kilograms equals a sub x. So let's multiply that out. We get A sub x equals 3.21. And we get newtons divided by kilograms, and newtons are kilogram meter per second squared divided by kilograms. So we get A sub x equals 3.21 meters per second squared. And that's what they asked for.